All right, everybody, we're starting up a new unit on rational functions. So this lesson is really just going to introduce to us what those are, what their equations look like, what their graphs look like, and some features of the graphs here. So real quick, rational functions are just polynomials divided by another polynomial. And those polynomials might be in factored form, they might be in standard form, so not factored. So let's take a look at what these equations look like. So all three of these are examples of rational functions. All right, so we've got a polynomial on the top and the bottom, not factored here, although you could factor this. Another polynomial divided by another polynomial. Again, this is in standard form. And then this one's factored. And so we've got a polynomial that's completely factored divided by another polynomial that's completely factored. All right. We're going to save what we do with those equations for another lesson, but this is just what the equations might look like. Again, standard form or factored form. All right, so I've got a graph over here, and this is just a sample graph of what one of these rational functions might look like. All right, so first off, rational functions typically have what's called a horizontal asymptote. So it's like an imaginary line that the graph gets really close to as we go further to the right and further to the left here. All right, and so I'm going to say this dotted line, that's our horizontal asymptote. We're going to come back to that in a second. But they also have what's called a vertical asymptote. So on either side, the graph is going to approach that line going up forever or going down forever. All right, and so right here, that is our vertical asymptote. This point right here is an open circle showing us that there's nothing there, and that's referred to as a hole. All right, and I went ahead and listed out the coordinate point for this one. It wasn't at a nice spot, so I just approximated the decimals as 3.5 and 1.8. Now, zeros. This is nothing new. It's just the x-intercept. So that's our 0 right there where it crosses the x-axis, and that's our y-intercept right here where it crosses the y-axis. Now, listing out where all of these are, so our horizontal asymptote is a line that passes through y equals 2. And so that's its equation. We just write y equals 2 for the horizontal asymptote. All right, so end behavior. This end behavior is a little bit different than graphs we've done in the past, but we're still going to use the limit notation. And graphs always have two ends to them. So we're going to talk about as x approaches negative infinity, so left forever for this function. I'm going to call it f of x. And we're also going to do that as x approaches positive infinity, so right forever. So on this graph here, if we were to go left forever, the graph is getting close to this horizontal asymptote here. And so as we're moving left, the y values are getting closer to that line at y equals 2. So as we move left forever, the f of x or the y values are also approaching 2. Even as we move right forever, as we go right forever, the y values are getting closer to that horizontal asymptote at 2. So if that was a positive infinity, this would still be a 2 here. All right, in other words, if there's a horizontal asymptote, that's what our end behavior is going to end up equaling here. All right, it's the same thing if there's a horizontal asymptote. Now, vertical asymptote. So the vertical line passes through the x-axis at x equals -3. So I'm going to write x equals -3 here, not just, a lot of people will just put -3, but we have to put x equals, it's passing through the x-axis. All right, so the coordinate point for the hole. So I've already listed this up here. I just want to point out it has an x and a y coordinate. We're going to be expected to list both here. So the hole is not just x equals 3.5, it's 3.5 for x. And it gave us the y value as well, which is 1.8. So that's the coordinate point for the hole. The zeros. I can either list this as a coordinate point, so -1, 0, or I could just write x equals -1. Same thing with the y-intercept. Either call that 0, 1, or just y equals 1. All right, so let's take a look at another. This graph has two vertical asymptotes. It has a horizontal asymptote on the x-axis. And the graph in the middle actually crosses through the horizontal asymptote. You might remember from Algebra 2, you might not. Graphs are allowed to do that in the middle of a graph, but towards the ends, they will approach the horizontal asymptote. All right, so in the middle, it's almost like it's not even there, the horizontal asymptote, but towards the end is when the graph will start to approach it. All right, so first off, we got a horizontal asymptote at y equals 0. Remember, even though it's on the x-axis, it's passing through on the y-axis. It's passing through at y equals 0, right? So that's why this is y equals and not x equals. All right, end behavior. So just to, if this wasn't clear in the last part, these two, if there's a horizontal asymptote, they're always the same. So our limit expression is just going to equal that same value of 0. All right, so as we go, I'm going to put a plus or minus infinity just because I'm low on space. But as we go left or right forever, the graph is approaching that y value of 0 where the horizontal asymptote is. All right, we've got two vertical asymptotes. So one goes through x equals -3, and the other goes through x equals +2. All right, so two vertical asymptotes. This graph does not have a hole, so not every rational function graph will have one. And we pass through the origin, so that's both an x and a y-intercept. So I'm going to put the coordinate point this time, 0, 0 for both of those. All right, one more. This one's a little different. So this graph does not have a horizontal asymptote. It has what's referred to as a slant asymptote. Now, graphs or rational functions will either have a horizontal asymptote or a slant, but not both. And so we'll go over in the future, like what conditions does the equation have to make it a slant asymptote or to make it a horizontal asymptote? But they're going to have one, not both. So the slant asymptote is right here. For now, I'm just going to write this as y equals mx plus b. And I'm doing that because it's a linear function, right? It's going straight. It's not curving. So I'm going to write this as y equals mx plus b. At the end of this example, we're going to go back and try to figure out the actual values for m and for b. Now, end behavior. So this one is not the horizontal asymptote. So we have to look at as we go left forever and as we go right forever. So as this graph, again, x approaching -infinity means left forever. As this graph moves left forever, it's moving down. So our end behavior here is that the y is going to approach -infinity. And then again, I'm low on space, so I'm just going to write over that one. But this is part of the end behavior. Then, if we go and approach +infinity, so it goes right forever, okay? So if the graph is moving right forever, it's moving up. So the y value is also approaching +infinity, right? So these are not necessarily the same, okay? Again, there's no horizontal asymptote, so we have to just look at the graph for these. Now, the vertical asymptote, that is just at x equals -1. And this graph also does not have a hole. It never crosses the x-axis, so there's no zeros. But it does cross the y-axis up here at 8. Now, the slant asymptote crosses at 7, but these dashed lines are not actually, it's kind of like they're invisible. They're not actually part of the graph. The solid portion is the graph. So the y-intercept is just at y equals 8. All right, lastly, the equation for this slant asymptote. So again, it's a linear function. Y is always y, x is always x, but this is our slope, this is our y-intercept. So we're going to get that from the graph over here of the slant asymptote. So the y-intercept of this line, not the function, but of the line is passing through y equals 7. And so our b value is just going to be 7 here. The value for m is just rise over run. So you could pick any points on here on this slant asymptote. I'm just going to pick the two that are on an axis. So from this point to this point, the rise, we're going from y equals 0 to y equals 7. So the rise is 7, and the run, we're going right to from -2 to 0. So our slope is just up 7 over 2. All right, and that would be the equation for the slant asymptote on this one. All right, so that's it for now. This is what we're doing mostly in class, is coming up with this information based on these graphs. And again, in the future, we'll actually get into how do we come up with these graphs from an equation. But that'll be another lesson for another day. All right, stay flawless.